Good morning. This is a recording in honor of Mr. Duarte, who is unfortunately rejoicing right now that he has offered up many students on the AP World altar as a sacrifice. May they be pure, holy, and pleasing to the Lord as they sacrifice their time, their effort. Oh, this is actually Algebra 2 class. So we're on number 15, so I'm told. I don't know where we stopped. Where do we stop? Log?
The next one.
Pause this video and restart from the beginning. Where you have log base 2, a difference becomes a quotient, y plus 2 over y minus 2 equals 1. And then what do you do to get rid of the log base 2?
You log.
It already has a log. You don't want to log a log.
Exponential.
You write it in exponential form. So if there's a log on both sides, you cancel them. But if it's in log form, you write it as a base of 2 to the first, and it's y plus 2 over y minus 2. And then to solve that, you multiply both sides by y minus 2, so you have 2y minus 2. And distribute, and you get 2y minus 4. Subtract y, add 4, so you get y equals 6. And this is not extraneous, because when you plug 6 in, you don't get log of a negative number. It's just log of a positive number, so it's defined. So that's logarithm. And the next one, when you have a variable exponent, you should log both sides. Turn the page. You log both sides, 3p log 4. You bring the exponent down with the power property, and then log 10. And then to solve for p, break out the highlighter. Solve for p, there's p right there. And then you do log 10 divided by 3 log 4. And then you can get that on your calculator, which I think...
A point 5537.
5537. And it's common with logs to round to 4 decimal places. If you want to round to 3, that's okay, but 4 is more sophisticated. If you deposit $300, interest rate 6%, compounded monthly, how long will it take your money to double? Show setup. I think I give you this formula on the either on the front page or on the next to the question that it is, so you don't have to memorize it. So we have a lot of variables, A, P, R, and T. So what's A equal?
600.
A is 600, your money to double. The principal is 300. The amount is 600, so that's doubling. Your interest rate 6% as a decimal, 0.06. And what is N? 12. Compounded monthly, N is 12. And you must be looking for T. I should give you a question where all the information's in the question. I think that would be funny. I give you all this, and I say, like, and over 7 years, your money doubles to 600. And not ask a question. That would be great for a final exam question. So, we plug the numbers in. You have 600 equals 300. 1 plus 0.06 over 12 raised to the 12t. You use the 12 twice. And how do we solve for t? You're going to log both sides after you divide by 300, and your base is by itself. This is your base, all this in parentheses, 12t. And then you log both sides. You have log 2 equals 12t log 1 plus 0.06 over 12. And then you do the same thing that we did in the previous problem above, number 16. You're going to solve for t, which is stuck in the middle there, right there. And you'll divide by 12, divide by log 1 plus 0.0612. And what answer do we get for that?
11.5813.
Oh. What's that? 11.5813.
5813.
So 11.6, what are the units?
Year.
Years. To find units, you can just look for your, well, it's always in years in a question like this. how many months are in a year? 12 months. So it's 5 years. It'd be nice if it were like seconds. 11 seconds for your money. On the next one, you have exponential equation. You want to subtract 11 first. You want to isolate the e equals -9. You're still wanting to isolate the e. Divide by -3. And now that the e is isolated, you do what operation? ln both sides. So you have 4x. The ln on this side cancels the e out. It's not there anymore. So you have ln3 left on the other side. 4x equals ln3. So x equals ln3 over 4. Be careful when you type in your calculator. If you want to type it all at once, you need a parenthesis right there. So the answer is 2747. And you should write decimal answers. Anytime you have a log or a ln, you should simplify it. ln, natural log equation, what do you do to solve? You e both sides. So both sides become exponents. ln and e cancel. You have x plus 1 equals e to the first. X equals e to the first minus 1, which is approximately 1.718. Great. Something like that. Just to remind you where the e button is. The e button's right here. It gives you the exponent, so it's a 1 and minus 1. You get that. A cup of coffee contains 130 milligrams caffeine. Caffeine is eliminated at a rate of 11% per hour. How long will it take half the caffeine to be eliminated from the person's body? I won't give you equations like this. I do give you the one that's this equation right here. And if you notice, these equations are actually really similar. The only difference is that you have the n isn't in it. This is compounded monthly. This doesn't have an n. So you have 1 plus r, 1 plus r to the t, bless you, bless you, bless you. And the variables p here is actually a here. So they're really similar, but I won't give you these two equations. Yes?
Well, that's what I was going to ask. I think if you're going to give it to us in the final.
Are you disappointed with me?
Yes. A lot. Like a lot. I'm not calling you a loser. It's just a lot.
I thought it was some like sign language for yes or something. Okay. So which equation do you use?
The second one.
Why?
Because it's eliminated.
So you have y-a-r-t, yart, y-a-r-t. Your rate is eliminated 11%. How long will it take is your variable t. The initial amount's 130, and you're going for half of the caffeine, which is half of 130 is 65. So you have 65 equals 130, 1 minus 0.11 to the t. Divide by 130 like we did before, you get half. This is 0.89 to the t. And how do you solve? Log both sides. So you have 1/2 with a log in front of it equals t log. So your answer would be t equals log 0.5 divided by log 0.89. Thank you. This video even includes visits by TAs. What answer do you get for this? 5.95 hours. This right here, the rate, lets you know that the units are hours. On to chapter 11, sequences and series. Just to remind you on your final exam, I will give you all the sequence and series formulas. Did you do that yesterday? Oh, well that's good. You should do it every time. Like maybe every 10 minutes. Like I'll say an answer. The answer is 5.95. better than grumbling. So I'm going to give you all these formulas. Arithmetic, geometric, blah, blah, blah.
Can you tell us which ones you need to study?
That's a good one. Find the next four terms. So you have -8, -5, -2. This is arithmetic. So you have d equals adding 3. Now, Anissa, when you say tell which ones to study, are you talking about these formulas that I give you?
No, like the ones that aren't here.
Oh yeah, I've been mentioning it as we go along. Midpoint formula, distance formula, completing the square, the one that we just did right above. You missed that part. I thought you were asking, are you going to tell us which ones you're going to ask on the final exam? You know, I would really study the infinite geometric series, specifically that. You don't really need to study the arithmetic sequence. I'm giving you both. So your d is 3, you add 3, you get 1, 4, 7, 10. The next four terms. The next one, you start at 12, you need the next four terms, you're subtracting 3, so you get 9, 6, 3, 0. Find the indicated term. No, Anissa, I will not put the formula to use right next to the question to use the formula. It's a little more complicated than that. So you have a sub 12, you have the first term plus n is 12 minus 1 times d, and what's d? -5. So we would have 8 plus -11 times 5. -47 is the 12th term in the sequence.
Could you show how to get D?
8 to 3, 3 to -2, you're adding 1.
Okay.
Find the sum for the arithmetic series. Hey look, the formulas are right next to the question. This is great. So we have a sub 1, a sub n, and n. A sub 1, a sub n, and n, so we'll use this one. The sum of 21 terms is 21 over 2, 76 plus 176, which is, no, 25, 2,000, help me out here, people.
2646.
2646.
Close.
Got the 2 right. Find the sum of the arithmetic series. So on one like this, how do we find the sum of the series?
First one.
You want to know how many?
Last one.
First one plus the last one
Times.
times n. Suspiciously, we don't know n. It's a trick. It's a trap. So you have to use the sequence formula. 98 equals 7 plus n minus 1 times d. d is 7 because you're adding 7 every time. When you simplify that, you would get 7n. n is 7 goes to 14. n is 14. So now we can do s sub 14, sum of 14 times 14 over 2, the first term plus the last term. 7 times 105 is 735. The next one is called what? Sigma notation. And how do we find a sum when it's written in sigma notation? Nobody knows. You plug in the bottom number, that will give you a sub 1. The first term you plug in the bottom number is 19 times 5 minus 3. So that would be 95 minus 3 is 92. Plug in the top number to get the last term. A sub n is 5 times 23. Oh, I kind of switched this, but hopefully you figure that out. 112. And then n is the number of terms. How many terms do we have?
5.
How'd you get 5?
You count from 19 to 23.
Yeah, you count 19 to 23. Or you subtract and add 1. Because when you subtract, you count in between the numbers. So you don't want 4, you want 5. So 5. So you have S sub 5 equals 5 over 2, the first plus the last. The alpha and the omega, the beginning and the end. Alpha and the omega. Reminds me of Revelation chapter 1. What do we get when we multiply this? 510? We'll go with it. You can check me, and then I'll go back and fix the video. Find the next two terms of the geometric sequence. And there's the formula again. So how do we find R in geometric sequence?
It's 710.
It's 710. What?
It should be 710.
The problem.
This one?
Yeah.
Really?
Yeah.
Okay. Sometimes my 5 looks like 7. How do we find R?
You plug in to the formula.
There's an easier way to find R. Well, what formula are you talking about? No. So it was 81 times something to give you 108. How do you find R? You take the second term divided by the first term, which is 1.3 repeating. Or at least in my head it is. It might not be, but we'll just say it is. 1.3 repeating. So to find the next two terms, you're going to take 144 times 1.3 repeating. We'll say that's 192. And then you take 192 times 1.3 repeating, and we'll say that's 256. And you can check my multiplying later. Find the sum for each geometric series described. And there's one formula. There's also another formula I'll give you, but these two you only need to use that formula. So you have the sum of 7 terms equals the first term times 1 minus negative half to the 7th divided by 1 minus negative half. Be really careful when you type this. Oh, it's just going to sit on my chair. It seems really dangerous to do this. It's like when Zach comes and pushes this from out underneath. That's protecting my night. 1 minus parenthesis negative half raised to the 7th. So that's the numerator. Divided by, and if you can, in your head, it's good to simplify this rather than having it use all the parentheses. So it's 1.5. 5375. And then we have another sigma notation. To find the first term, R and N is all we need. N is from 1 to 6, so that's 6. Notice it's not 5. From 1 to 6 isn't 5. It's 1, 2, 3, 4, 5, 6. 6. R is the base in here, negative 3. And a sub 1, you can do one of two things in this case. You can plug in 1 here, and you get 2 times negative 3 to the 0, which is 2. So to find the sum, you would have the sum of 6 terms equals 2, 1 minus negative 3 to the 6th, divided by 1 minus negative 3. And you can let me know what you get when you multiply that out.
What do you have? Like, what is the negative 3 raised to?
Negative 3, oh, that's a 6.
On the bottom.
This one?
No.
This one?
There.
Oh, that number? That's a fish swimming downward. So, yeah, it's a wormhole. Okay, pendulum swings 40 centimeters initially, and then only 95% of its previous swing. What's the total amount of pendulum swingage? So we don't know n is unknown, so we'll assume that the pendulum goes back and forth a lot. So we're going to say it approaches a very large number. So we'll say it's infinite. So we use an infinite sum. And our first term is 40 divided by 1 minus 0.95, which is 40 over 0.05, which sounds like it's 800. And remember units, 800 centimeters. Find the sum of the infinite geometric series. There's the formula that I just used right here. Beware of divergent series. What does it take for the formula to be valid? Anyone remember? What does it take for this formula to be valid and not divergent, but to actually get an answer that is not like an extraneous type of answer? So it's something with R. R is between -1 and 1, and then it's okay. If R is greater than 1, or if R is less than -1, then the series diverges. But you won't be able to tell just plugging numbers into the formula. You can get numbers, plugging numbers into a formula. But the right answer, the valid answers, only come when R is between -1 and 1. So for the instance, this one, R is between -1 and 1, so it's okay. So if you have an infinite series starting at 4, and the rate is 5/7, when you simplify that, you would get 14, partial sum of 14, or sum of 14. The next one, we need to find R. R is -18/12, which is -1.5, I guess. This would be too big of an R. So you're always going to be adding numbers that gradually get bigger and bigger and bigger, so there's no way that you can approach one single sum, because the numbers you're adding keep getting bigger, so your sum keeps getting bigger. So this is no solution, does not exist, or divergent. And then notice the next one, what's your R? Got an infinite up there. R is 3/2, so this is no good. It is not between -1 and 1. So that's also undefined, or divergent series. To find the first 3 iterates, given you start at 5 and there's your function, how do you find iterates? Iterates.
So you plug x of 1 into the so x of 1 equals.
So you plug 5 into that and you get 17. To find the second iterate, you plug 17 in and you get 65. To find the third iterate, you do 4 times 65 minus 3 is 260 minus 3. So they're the first 3 iterates. Pascal's triangle. How do we write Pascal's triangle?
1, 1, 1, 2, 1, 3, 3, 1, 4, 6, 4,
1,
5, 5, 10, 5,
7. Did you say 7?
no.
1, 5, 10, 10, 5, 7. So that's Pascal's triangle. The next question, you're using Pascal's triangle to expand. So I'm actually going to show my setup over here, a little better planning, and then I'll write the answer below. But what's the process to expand a binomial? It probably won't say on your final exam, it might, to use Pascal's triangle, but it might not. It might just say expand the binomial. So you're going to use Pascal's triangle.
We use the 5th row of Pascal's triangle. Write it
Fifth
down.
row. We have a guest speaker in class today.
Okay.
10, 5, 1.
And then you write the exponent, you do the opposite exponent, but you need the x in the one. Like next to it, you know? Yeah, you do.
it's 3x, so it's
Like
4,
5, 4, 3, 2, 1.
Oh, that's what you meant.
Yeah.
So you go 3x to the 5th,
Kick her out.
3x to the 4th, no mutinies please, 3x to the 3rd, 3x squared, 3x to the 1st, and then no 3x's. Make sure you use parentheses. If a student's going to miss anything about it, then they usually miss 3 to the 5th, and they don't actually do 3 to the 5th. They just do 3x to the 5th. And then the 1s are going to start at 0 and go uphill. They don't actually do anything in this case because it's just 1. But I'll show you it all just in case you get one on your exam that isn't a 1 there. There's one other thing that you have to be careful about.
Plus, minus, and go down.
They're alternating signs, so you start with plus and go back and forth. And then you simplify all that. I can do a couple of them. 243 x to the 5th. What's that? 381 times 5 is 405. Minus 405 x to the 4th. That's 27 times 10. Plus 27, blah, blah, blah. 9 times 10. Minus 90x squared. 3 times 5. Minus 1. So that's your expanded binomial. That takes us all the way to chapter 12, and we'll continue chapter 12 tomorrow. For homework tonight, if you want to look at those, see if you remembered how to do those codes again. You can also find spare copies of this packet on Blackboard. Thank you for listening. Thank you for being in class. Thank you for watching this video.